talks where I'm honored by having Dave McDermott from aPriori and Paul Hames from PTC for a session on making product design manufacturable with aPriori. But first, a very quick introduction by myself, and my name is Torbjörn Peterson. I'm the Alliance Manager for PTC in the Nordics, leading these weekly webinars where we invite customers and partners for some inspiration on digital transformation to see what is possible and how to make things happen. And we are running all these webinars on Fridays, same time, with topics around either manufacturing, services, or engineering. And all the recordings of the past seminars have to be found on the registration site. The agenda for today is first a very quick overview of PTC by me, and then Dave and Paul will run the show where they will touch base on a few challenges, how to address these, and then explain some of the business outcomes. And at the end, we're also having a Q&A session, so please keep your questions to the end, or you may also put them in the chat. We will pick them up during the Q&A. Next slide, please, Dave. So just a very brief overview of PTC for those who don't know us. PTC is a global software company with a headquarters in Boston, and we provide market-leading solutions on IoT, augmented reality, PLM, CAD, SLM, and ALM through the digital thread to help companies to accelerate their digital transformation. So now over to you, Dave.
Sorry. So about aPriori, well, the best way to describe what we do is to show you how we're going to impact manufacturability. Now, most of our customers begin their digital twin journey by looking at capturing the digital twin. And we in aPriori believe that they may limit their strategy by focusing exclusively on that. Now, PTC offer a broader view of the digital twin, but aPriori use a slightly different technique. We create a digital representation of the manufacturing process within a digital factory that allows us to draw out insights. Those insights form at many levels, down at the geometric level, the part level, the assembly BOM, or even the whole entire year's production run level. These insights can be used to support very important decisions in a world that is dynamic, changing, and I think we also over the past few years was really problematic for companies. Manufacturability has always been a problem, but in the last few years, manufacturability issues meant that we couldn't get material to make parts. And this all comes down to one of the most important things for companies, of course, which is cost. So combining manufacturability into the cost and today carbon footprint, we can help companies make decisions much earlier on in the product life cycle, support what they're trying to do, be profitable, sustainable businesses. How does that fit in with the PTC product landscape? Well, most of you out there are using Windchill and Creo, so you will have a product definition that looks like this. We at aPriori provide a cloud platform that will take insights from Windchill, the CAD parts, the BOMs, assemblies. We take some basic production parameters like what they're made from and the types of components they are, and it allows us to run an analysis. And that analysis produces some manufacturing insights that we pass back to Windchill so we can populate the bill of material with cost information, sustainability, and manufacturability insights that tell people early on in the process how difficult things are to make. And that's really powerful in a stage gate process. At certain gates in the life cycle, this information becomes valuable to allow us to progress to the next gate with a design that's affordable, sustainable, and easy to manufacture. So what does that look like inside Windchill? So here's my Windchill environment, here's my product, and inside my product, I'm still working on some of these components. This little part here is halfway through its design stages. It's not completely finished, yet aPriori has already provided me insight that goes back into Windchill, and this is it. This document here has a list of data that came from aPriori. At the top here is what aPriori read. This is a stock machine component made of this material here. Immediately, it provides me with a rating and a score around manufacturability. It's looked at it and said, this isn't that easy to make, and it tells me that here. Supporting that is information about material utilization, the cost of the material, the cost of the final part, as well as sustainability information. This is the carbon footprint of that component in production. These insights build up a picture of manufacturability and cost and carbon that allow me to decide whether this is ready to go into production or to progress to more detailed design, where I'm doing FEA and tolerance analysis and things that are going to consume engineering resource. I only want to do that on things that are ready and good. So Windchill now has this greater level of information that can be rolled up. And these roll-ups can be done within the context of a product structure. So I can now create reports that show me how well I am doing against my targets for cost, carbon, and quite frankly, manufacturability as well. These red circles represent high costs against the design progress. I'm only 3/4 of the way through, but I'm already nearly over my cost target. Some of the things behind that are manufacturability problems. And the job now is to go and find out where they are and why, and do something about them early in the life cycle. So here's what we do. We create a more detailed evaluation of what's behind all this inside the aPriori world. And these interactive visual reports can support the design teams, among other people. For the design teams, they can go from Windchill. So let's go back to our Windchill page here. Here's our component. It's got a high score here. And here's a little URL, a link that takes me through to the actual component that's got a problem. So for design people, I can see what aPriori did when it ran its analysis. It, first of all, came up with a manufacturing process. This is a machine component, and it's suggesting 4-axis mill is the best thing to use to go and make that component. And it's got cost information as well. But for design people, this level of insight tells me that when it did the analysis, it found that it needed long tools to go and manufacture some of these surfaces and faces. And it's even suggesting what ratio of depth to diameter the tool needs to be. In other words, I've designed in small, long fillets that aPriori is telling me is a problem. And here's some guidance to support design people on why that is a problem. I'll cover that in a minute. But basically, I get to see problems. And I can go about solving these problems immediately, coming up with a new design which has got much bigger fillets in here. They're easier to make with a bigger tool, reducing cycle time and therefore cost. And then I can create comparisons of one design to the other. So at the left-hand side here, this is the design which was difficult to manufacture. This is my new design that's easier to manufacture. And again, my yardstick for manufacturability is cost. And down here, I can see a fully burdened cost that, if you look down this box here, nearly 23% lower. That's fantastic. And I'm doing this way before I finalize the design. I'm already reducing cost and making it more easy to make because I have these insights. Deeper insights also show me where I am wasting electricity, setups, materials, and resources that point to other manufacturing techniques like casting. So aPriori gives me indicators that say this could be cast. And if I designed it for casting in a slightly higher volume, production volume, I can take another 90% out of the cost. So all these little insights point to ideas and concepts I should consider early in design. I take them on board and I make better products. As I'm doing this for this plastic component here, aPriori is tracking a history of every design iteration I make. So I have a physical plot to show me where I am against my carbon or cost targets. And I can also plot this against DFM, design for manufacturability. So here I am maintaining manufacturability on this, making it easy to make and bringing down the costs at the same time. Now, it's not just simple components like this. To aPriori, it's just mathematics. Some of our customers create analyses of very complicated components and bills of materials. It's just maths to aPriori. It crunches through all of this in the cloud to present information about not just one component, but every component in a bill of material. Each one of these has a manufacturability score at the left-hand side, cost information, carbon information. So I can build up a picture of a bill of material that goes back into wind chill where people can interact with it in the life cycle. Very powerful. It does, however, beg a question that if I have all these great insights, I can't go and look at absolutely everything. So the real focus now is, where do we find the best parts to focus on? Luckily, all these insights can be looked at multiple levels. So for example, I can take a series of components and plot them on a graph like this. This is cost versus weight for machined components or cast or sheet metal with the same material type. And you see there's an average there, all these components about the same dollar per kilogram. This one here is higher. It's more expensive per kilogram than its peers. The size of the bubble represents the annual spend on that component if we went into volume production. Therefore, big bubbles are big cost problems. And the color of that bubble, purple means bad. It's a high score on the manufacturability table. It's got lots of manufacturability issues. So that is my first component I want to focus my engineers, my cost engineers, value engineers, manufacturing engineers, to support the design teams to say, let's make an impact on this before we commit to final production. And for that component, we can see what it is, its high score, some of the attributes, and we can dive into that visual report to find out more. Or we can look across a broader spectrum of components that's on that table and look at all the manufacturability issues, see which ones are standing out. So a lot of, in aerospace, for example, a lot of components require complicated surfaces that need to be machined in a contouring operation. It's expensive. When we start to see lots of these, we could possibly educate the design teams on things they should consider or things they could possibly avoid. Another way of looking at the data behind the scenes is to look at cost per kilogram for multiple manufacturing techniques, but include carbon into the equation as well. Because we have to be careful at trading off material carbon, process carbon, and the design for manufacture and the design for cost all at the same time. This graph here represents, up the vertical axis, the cost per kilogram. Along the bottom axis is CO2 per kilogram. What I'm looking for in this graph is anything around the periphery. This component over here is a CO2 problem. These components up here are cost problems. If I use carbon and cost as my measures for looking for issues, I know where to begin looking for manufacturability issues, real ones that are impacting these factors. So the analytics can be elevated to a broader spectrum, filtered by product, production run, or even everything that we do, to allow me to find the things that I need to focus on as a business. And then what we'd really like to do is analyze this on demand. I find components that are problems, and I would like to be able to, directly from my CAD tool, get instant insight from them. So this is another component in that e-scooter there, a small bracket, an insignificant component. If I look down here, it costs $6, a cheap bracket. Now, if we go into extremely high volume production, then that starts to become expensive. So on this component, if I look at the manufacturability issues on it, there are things that are driving potential yield issues, cycle time issues. Like, for example, if I have holes that are countersunk or bends that are problems, then it can introduce complex tooling. I have here a tolerance stack up, a classic problem that we see in components. And aPriori says, well, there are going to be more than one bend to create some of these features. And here's some guidance for design people that they should think about when trying to avoid it. aPriori is not going to do the analysis on tolerance stack up. It's telling us that if I continue down this design path, this is another engineering problem I'm going to have to solve. This is another potential production yield issue that will cost us money at the end of the day. The interesting one on this is that we have, out of all the other different issues, a low utilization of material. So aPriori said that this production process Optimal is progressive die to go and make this. It's suggesting that the utilization is lower than it should be for progressive die. How low? Well, actually, aPriori can show me that. If I look at the manufacturing process itself, progressive die in terms of cost, progressive die is the hardest one. This is the largest one. And that's because we're nesting this component in a metal strip. And this is how it needs to be nested based on the flat pattern design that aPriori has analyzed in its digital factory. The dark blue represents wasted material. That's scrap material. So lots of dark blue is a problem. So design people could see this and start to think about how they're going to solve that problem. How do we do that with aPriori? Well, I go back to my CAD tool. In this case, it's Creo. I make a change to my design. And believe it or not, to make this component cheaper, I'm actually going to make it bigger. So I increase the size of my component, which sounds counterintuitive for a lot of design people. And then I send it back off to aPriori to go and do an analysis. And what happens here is that it sends the CAD data directly from Creo up to aPriori's cloud platform. It then goes through a series of little processes to be analyzed and got ready for analyze. It produces a series of internal reports. It does thousands, sometimes millions of number crunches up in the cloud. And while it's doing that, we just carry on doing what design people do. We go about designing, we go and work on our drawings, we do these things. Meanwhile, aPriori, as you can see up here at the top, is doing some number crunching in the cloud. What it actually does is take every feature of that CAD model. Let me show you again. This CAD model has bends, forms, punches that are defined in any way inside the CAD tool, but it looks for these features as manufacturing features. And for each one, it does an analysis of how it's going to go and make it. And it builds up a picture from flat pattern to final part of every feature that needs to be created, so it can calculate the cost of the tooling, the components that go into the tool, the cycle time for each clunk of that machine, and how much material is going to be scrapped in doing so. If I look down the bottom here, we are bringing the cost down to $5.45. It's come down. Why is that? Well, if I look at the way in which it's nested in its strip, it's much better, isn't it? Now, that's a counterintuitive design decision. In fact, what would happen in the real world is we would make it smaller and actually impact the cost negatively. How do we know if we've done well? We can run these comparisons that compare the original design to the new design. And if I scroll down here, you'll see in my comparison that I've got a considerably considerably lower cost. Down the bottom here, fully burdened cost down 13%, or about 85%, 85 cents rather. That for a 100,000 components a year product over 5 years is about $420,000 for a tiny little component like that. So imagine what it would be if it was a larger component or a larger set of components. And all these little analyses of manufacturability to make small impacts on every component, sometimes big ones like this, that allow us to make things easier to make and bring down cost. So that's great for design teams, but there's a broader enterprise in most companies, and these insights support everybody. Procurement, for example. Now, procurement, they want to negotiate fair market price for components and low CO2 and low cost supply chains at low risk in political zones that are not susceptible to turmoil. That's what they want to do. When it comes to manufacturability, we have several customers who will stand up and publicly say they are paying money because the suppliers are their manufacturability guides. They use their suppliers to help them design for manufacturability. Their suppliers charge them for that. They don't know it. It's in the price of the components. These suppliers also get a little bit tired of having to and fro between the design teams. So aPriori provides insights to design to support procurement because they go to procurement with designs that are ready to be made, but also it gives them insights to allow them to make really powerful decisions. This is a graph here that shows me For everything that I'm manufacturing a year, the complete material requirement, including the material I'm going to scrap, not just the weight of the parts, but all the material I'm going to use. This red bar represents my highest volume material. This is a grade of aluminium, which if the price of that material starts to rise, or that material becomes unavailable because of supply chain disruption, my manufacturability drops to zero, or goes to infinity rather, because I can't even get the parts. From a cost perspective, that's the one we're most exposed to if that material grade goes up. So we can think about spreading the risk of cost by looking at making designs of a variety of materials, or focusing on a single material where we can get higher volumes and therefore lower purchase price based on volume. So for procurement people, these insights can help them around manufacturability and ultimately cost of procurement. Plant managers, well, they're thinking about manufacturability with respect to something very special, which is their actual facility. And in their actual facility, when they're making things, they have a finite number of machines of certain types. The analysis that aPriori does tells us what machines are ideal for making each component and component type. So we get data that supports capacity planning for manufacture. And where we start to see an increase in requirements for, say, 5-axis machining or vertical casting, we can start to see where there's going to be a problem in supporting our production facilities so they're not overrun and we have to go to the supply chain. So manufacturability for the shop floor means, can I actually make it, or do I have to outsource it at great cost? And then finally, the value engineers, manufacturing engineers at the bottom right-hand corner there, they're able to support a broader part of the business because they get insights at the same time that design people do. In fact, they get a greater level of insight. This is that same component from earlier on, but this time for cost engineers, for example, they can see what the optimum routing was for this component, 4-axis mill. This could be turned, but let's say we have a production facility or a supplier that have lots of milling capacity. So that's the analysis done against somebody's actual capability. And then the manufacturability guidance is based on that capability. For a design person, this looks like a nice, easy shape to make. Is it? Well, here's a list of design features or surfaces that are driving cycle time. And right at the bottom of the list here is the heaviest one. To make this surface requires a contouring operation. That's why it's on this list. And it doesn't look like much to the average design person, but yes, you can see at the top there where I've got a planar surface meeting this curve here, it's going to form a domed surface. That cannot be machined with a flat cutter easily. So I have to use a contouring operation that drives cost. So with the expertise of manufacturing people, they can get to see that and they can offer their suggestions and comments back to the rest of their organization and ultimately back to Windchill, where they can take this analysis that was done in this component and produce little reports and markups inside this workspace to say, as a manufacturing engineer, I would like you to consider this, Mr. Design Person, Mrs. Design Person, because if you can, it saves us $500,000. Any chance you can go and have a look at that? So the whole organization can think about manufacturability, can collaborate on manufacturability with insights that are provided much earlier on in the process. And that's how aPriori we're helping organizations make it a reality and avoid some of the problems of the world, especially around the cost pressures that they've got to address. Okay, so I'll stop there and we can open up for Q&A. Torbjörn?
Yes, sure. And thanks a lot for sharing a lot of cool stuff here and the cool demos here, Dave. And actually, first question will go to you, Paul. So, I mean, Paul, we have heard a lot of great things from aPriori here on their offerings and how they positively impact the manufacturability of a component. So can you please comment on how the digital thread provides scope for impact across the product lifecycle?
Yeah, Thanks, Torbjørn. Great question. And thanks, Dave, for a really interesting look at aPriori and the technologies there. And I think when we look at what is possible within the context of the full digital thread, including, manufacturing, engineering, and service, beyond what we've seen from Dave today, there's other areas that, of course, we can have an impact on manufacturability. So, for example, multi-bill of material management. So the ability for us to help companies with initiative things like that are sometimes described as manufacturers designed. So this is all about understanding that companies do struggle to manufacture as designed components in different factories because of different supply chain challenges, different processes, different equipment, and often because they're making products for different markets. And so the ability for us to manage an engineering BOM and then transform it into any number of manufacturing bill of materials is, I think, a fundamental area that we can help customers and companies become more resilient to changes in their individual markets that they sell into, but also to ensure that what is designed and what is actually then made in the factories represents that as designed view. So again, it's called bill of materials transformation, multi-BOM management, but it's about moving from the engineering BOM with an associative manufacturing BOM. Again, because then changes that happen at the engineering departments actually then replicate through the manufacturing bills of materials as well. But it goes broader than that. Things like parts reuse, I think, again, that's all about trying to rationalize the number of individual parts that we have on our inventory for within a business. Any component, costs something. If you're going to introduce a new component, it's something between $5,000 and $20,000 as a cost to the business to develop and maintain that. So the ability to classify components, search for those, so engineers don't recreate things that already exist within the business, obviously is a huge benefit. And then I think there's things like platform management, variant management, helping companies respond to wanting more customer-focused products, but still being able to offer that personalization, but being able to manufacture based on, let's say, a modular product architecture or variant management. Those are all areas that I think that digital thread capability provides, which builds on top of the things that we've seen from Dave today. So yeah, really interesting area and a lot that the digital thread can deliver.
Thanks a lot, Paul, for your great overview. So I had one question also from Ryan Bateman here in the audience. And that is, based on your experience, what is the onboarding time to use the whole platform that you have demonstrated here?
Sorry, I missed the start of it. Cut out there, Torbjørn. Do you want to say that again? Sorry.
Sure, no worry. It was a question from Ryan. He is asking, based on your experience, what is the onboarding time to use for the whole platform?
Onboarding time, yeah. We have customers who get value from day one. There is little learning to do from the design perspective. There's some configuration to do to model those real world digital factories, but they can get value from day one. One of our customers, I can't remember if I can mention their name or not, but they got their money back within 2 months. So you can onboard quickly and then spend the next year or so integrating it in part of the real business processes, especially with respect to lifecycle management. So it can be very quick.
Thank you. And I had another question from Samora. I think, let me see here. When you have a low risk design for manufacturing, CO2 is less than for high risk design for manufacturing. Is that correct?
Actually, there is a kind of complicated equation behind that to present those numbers. Our customers in reality use the data in slightly different ways. So the risk ratings can vary depending on lots of factors. They just use the raw numbers actually in reality. So yeah, no, there's a lot going on behind there. Thanks for the question.
Right. And another question here regarding return of investments. What's the normal? Do you have any average numbers on return of investments?
Yeah, we do. We had, so the Forrester group have done some analyses, and this number 5% keeps coming back. So it tends to be that most customers get 5% return on everything that they go and study with aPriori. That tends to lead to a 10x return on an investment. Some companies get millions out of what aPriori brings back, and they've spoken at our customer events. So it can be an extremely high return on investment, especially if you're looking at high volumes and high spend on material. Yeah, significant.
Right. Could you also, I had one question here regarding sustainability. Could you elaborate a little bit about how design for manufacturing is actually driving sustainability?
Well, of course, there are many levers on CO2, the main one being energy use. So if we make something difficult to make, it tends to consume more energy that drives CO2. The top one usually is material. Most of the analyses is about material carbon footprint. And each process group has its own issues. So in machining, for example, we could make something just a little bit bigger, and all of a sudden you're using a much bigger stock size, wasting material in the actual consumption you buy, and also in the chips you make in that process. In the process for plastic injection molding or die casting, well, we can look for all the areas that are consuming energy, like thick areas in die casting that take a long time to cool, and then bring that information early on to allow design teams to say, well, actually, maybe we could look at a design that uses less material.
Right.
And we can understand the impact of that from a design perspective.
Sure.
There are many ways.
Right. One last question here. Do you have any kind of, tips and tricks about, how to get started with any kind of, successful design for manufacturing product, and who should normally, get involved from the organization at the customer level?
Great question. Difficult to answer without any context, but quite simply, we can provide the data that you can analyze to find opportunities. Each of our customers is very different. Some of them use a value engineering team. Some of them do this with design people who are manufacturing conscious. Some of these are using young design teams that are brought in, and from day one, they're looking at manufacturability. There are many ways. So we have a success planning process using people that we brought from PTC, actually been doing this for years, thinking about adoption, process change management, to allow companies to say, well, is there a better way we can work? So that's something we can help with, if that answers that question.
Fantastic, thank you. And folks, time is unfortunately running out, so many thanks for joining this session here today, and a special thanks for Dave and Paul for sharing a lot of good stuff here. So with that, I hope to see you back already next Friday with another session with aPriori on harness the power of AI for immediate impact, a quick wins for business transformation with aPriori. So looking forward to that, and have a fantastic weekend, everyone. See you next week.
Thank you. Bye-bye.
Thank you very much. Bye-bye.